I have a Gemini capsule for the Gemini Protocol here, and right now it's static content. But of course, I wanted to add dynamic, content eventually, and I prefer to do that using my own server library. So I built one. It's called Wallawood, and you can see that it's MIT license here. And I've designed this library to be generally usable, not just for my purposes, but for anybody. And it's published on Maven Central, fully open source. You can do whatever you want with it. Purpose of this video is just to tour some of the features of that library. And we'll be doing that by using this repo, which just sort of carefully demos not every single, but just like the main features. Well, let's just git clone this instead of me just bantering here. And let's see if we can run it. Just make sure this command does not fail. Create W and then W run. All right, there it is. My server is up and running. You will need a Gemini client to sort of follow along here. My preferred Gemini client is Lagrange. Of course, there are other clients. You're more than welcome to use whichever one you want. And Gemini Protocol is, in general, trust on first use. So you will have to trust it initially. But after that, once Lagrange knows about localhost, you're good. Notice I didn't have to mess around too much with TLS certifications. The library sort of handles all that for you if you haven't provided a certificate. But let's start with sort of the basics here. The first question you might ask is, where is this coming from? And by default, my library looks for this static directory in source main resources. And inside the static directory, I have an index.gmi, and the server will just serve up the index.gmi. And of course, you can just take a look at that. It's this exact same thing that we're looking at right now. You will notice that we also have a contact.gmi, and if I navigate there, it'll serve it up just fine. Notice, let me see if the zoom functionality here works. Yeah, so I don't know if you can see that, but the URL is localhost/contact. There's no file extension at all there. I wish we could zoom further. Is there a way to do that here in MacLand? Yeah, there it goes. Okay, very cool. Now, if I were to, my God, it's small. Okay, no worries, we'll work around it. If I were to now navigate to this pets directory, and I click in here, it will automatically look for index.gmi. That is the correct behavior. Notice I did not have to type in /index.gmi. It just looked for it on its own. Now, if I click on cat, you'll notice that the URL, I don't know if you guys can see that. Definitely mobile people will be having trouble here, but the URL says localhost/pets/cat. And there's no .gmi or anything like that. Why is that? Well, my library first looks for a cat directory that may or may not have index.gmi in there. In this case, it doesn't. And if you can't find the directory, it will look for cat.gmi and then serve that. The end result of all that compute is a very clean URL for your users. And that's what I wanted for my capsule. And if you want that for your capsule, I do have that functionality in there for you. Of course, we have protection against directory traversal, and we don't serve dot files or follow symlinks or any of that stuff. So hopefully you guys will benefit from that as well if you decide to use this library. Well, now there's something weird here. I have a dog and a fish, but those don't exist over here. If I click into them, they're there. What's going on? Well, if I go back to the root of my directory, I have this application.properties file here. If I click that, you'll notice I'm defining an ordered list of other static sources. So for example, I have a public directory in the class path. I also have this demo file on my file system, and I can specify those, and my directory will not just look in static, but it will now look in those other sources in order. And when it first finds a matching file path to the route, that's what it serves, right? It serves in order: first class path, then public, then file demo, and it will serve the first one that it finds. So that's really useful. It's really useful for a lot of different things. One of them happened to be for very large capsules. If you want to do separation of concerns, this is one of the ways you can do that. Okay, let's keep chugging along here. Well, I should show you, where is this fish and this dog exactly. So fish lives in demo/pets. This is the fish.gmi file. And then the dog sort of lives here in the source main resources, public/pets. There's your dog. So that's also very cool. Very, very cool. Now, Gemini Protocol really, really pushes for simplicity. That's why I have it set up so that, static resources, if they exist, will be served for any particular route, if they exist. But if they don't exist, then the next step is to check for dynamic content. And I guess I'll show you the most simple example here of dynamic content. If I click on this hit counter, I have this cool little functionality here: visit number 1. If I click again, visit 2, again, visit 3, and I can keep going. It'll keep incrementing. So this Gemini Tour sort of repository will tell you exactly where to go to find that functionality. Let's go there and see what's going on. We'll go into the code, into routing, and the counter controller is what we're looking at right now. And what's happening here is I have taken this class, this Java class, annotated it with this, and my library now knows that this is a Gemini controller, and I should register this path. Which path do I register? We have this sort of path annotation, and you can just register it. One thing to note here: it's not a get path, right? That's an HTTP concept. This is just path. There are no verbs in Gemini Protocol land. So this is a very Gemini native interface. The other thing here is we just have an atomic integer. We're incrementing it, and then we're sort of serving that up. That's all that's happening here. So one more thing to point out is that a handler must return a Gemini response. And this is something that I provide. It has encoded in it all of the all of the possible responses that you could need that were defined in the Gemini protocol. Plus, it has a custom method in case you have like an application specific sort of protocol that sort of, is a subset of the Gemini protocol, if you will. So you have full flexibility here. As long as you return a Gemini response, my server will know what to do with it. Okay, very cool. Let's now continue and see some more advanced stuff. Let's go to greeting. Okay, here's a really good one. So right now, this greeting controller says hello world. And if I were to sort of magnify this thing for some folks, see, you'll see greeting is hello world. Let's change that to greeting is hello Bob. And I hit enter. You'll see that the query string is coming through and the greeting is changing to hello Bob. Hello Bob. Okay, let's having too much fun with the magnification thing. Okay, very cool. So how is that happening? Let's go to the greeting controller and find out. So again, we have Gemini controller. I don't even know if you can see this window all that well. Let me zoom this in. But you can see that I have the same setup here. It's returning a Gemini response, but now we also have demoing query string, right? You can use this query string annotation to pull the query string if it exists. It'll pull that right out. And I have string here. Oh boy, I have string here, but type coercion is supported. So if you want this to be an int or a long or whatever, or a float, it will attempt to type coerce to that type. So that's really nice. Let's continue here. Let's go back home and oh, one more thing to mention. If a query string is not provided, this string might end up being null. This string might end up being null. So there's an NPE risk here. Actually, I don't think there is. How does string concatenation happen here? Let's just double check here. Is there an NPE risk here? Let's just get rid of this query string and maybe we get an error. No. Oh, this thing serializes to null. Very interesting. Did not know Java did that. Okay, let's keep chugging along here. Let's go to word search. So these are some utility methods. I'm not going to spend too much time on this, but I just wanted to show you that you have it. Let's very quickly show you the URL here for anybody who's on mobile. You can see that there is localhost dictionary search. Let's query for S. Okay, these are all the words that contain the letter S. What if we remove all of this stuff? Oh, so it picks up a query string as, ooh, let's get rid of the magnification. Picks up the query string as blank. That's an interesting behavior. Let's figure out where that is. Okay, dictionary controller. Let's go to dictionary controller here. So I have a list of words, and we're essentially filtering on the words based on the search query. Default, if this ends up being null, we'll default this value to a empty string. And then query param is sort of an HTTP convention where the query string is in the format of key value pairs delimited by an ampersand, and then each key value is delimited by an equal sign. This is an HTTP thing, but because the Gemini protocol is so flexible on query strings, this exact functionality actually fits snugly. Like you can format the query string however you want, including as a query parameter, HTTP style query parameter. So I thought, okay, let me just support this. Why not? It's sort of a gray area. So that's what this thing is doing. Not going to spend too much time on it. Those are utility methods that ship with this library. Let's just keep going back. Let's go home. Okay, next one is path param. This one is actually important. Okay. So notice that in greeting, the query string could be null, but you can do something to guarantee that that query string is not null and not empty, and that is to require an input. That's actually a Gemini response, status code, right? Let's just demonstrate it first, and then I'll show you the code. If I click on user profile, you'll see that the client is giving me this prompt, and I can now tell it my name. My name is Adil. Okay, send it. And the query string is now populated with my name because that's part of the protocol. That if a server returns require like input required status code, then the client should prompt the user for some input and then put that in as a query string. That all of that stuff is taken care of by, let's go to user controller here. All of that stuff is taken care of for you by require input, right? The prompt that you saw came because, excuse me, it came because of this require input annotation. And the require input annotation populated this query string with my name. So I could, Jimmy this thing to be like, hey, my name is Bob. And now it says Bob over here because that's how it populates the name, right? I should also say we have a path parameter, which is ID. So the path here is user/42, and it loads 42 by default. But just to show you that the path parameter parsing is working, I can go to 002, and notice it reads that just fine. So that is very Jakarta-esque. Jakarta has a path param annotation, and wherever you see me using a Jakarta annotation, you can actually just use the Jakarta annotation directly. You don't have to use my version of it. Like I'll read both, Wallawood annotation as well as Jakarta, and then implement the behavior as needed. So that's pretty nice. And that is I would say a nice demo of some of the most important annotations. There are more, but I don't want this video to get too long here. Let's go now into things that are a little bit more complicated, which is client identity. Okay, awesome. So let's click in here, certificate plus request URI. What's that about? So I can see here that my request URI is localhost / who am I. I'm not going to magnify this because you can see it right here. And the protocol says you have to have a URI, so you will always have a URI. But optionally, the client could send over a certificate. If I click on identities here, I'm using this X certificate here. So it reads that certificate. So how does that work? Let's go to the certificate controller in context. Okay, let's go back to and find context. Certificate controller. If I scroll down here, this who am I endpoint has this context annotation, which is very, very important. You can pull the request, you can pull this item out of the request context and just use it in any one of your handlers. So every request is going to have URI. It will always have a URI. Now you don't need it because I just showed you a bunch of ways you can parse a URI and whatnot, but you can pull the URI object if you need to, and parse whatever you need to from that. But also the user could optionally, or the client could optionally send a certificate with the request to identify the user. And the way you get that is with context X509 certificate. And this is going to keep happening, isn't it? Okay. This is how you would do that. This X509 certificate is coming from Java security. It is not something that I implemented. It's something that's provided to me. What I did implement though is a utility. The cert util has some handy methods for working with certificates. So for example, if you want to get the name out of a certificate, you can call .name and you'll get a name out of it. And the logic in there is whatever is the industry standard way to get the name out of a certificate. So that's not something you're going to have to think about because you have that utility. you also have this fingerprint method, which will give you a unique string that is key to this specific certificate. And if you use this fingerprint method, you get a string that you can save in like a database. And the next time the certificate comes along, you can match that, okay, I've seen this user before, this is that user, and this is his name, right? So very cool. That's going to be very useful. Now, if the certificate util does not have a method that works for your use case, like maybe you want to look at an issuer, I'm giving you the certificate, dude. Sorry. I'm giving you the certificate. You can process it however you want and get whatever you need out of it. Right? So very, very important. This is all protocol compliance. Okay, very cool. One more thing. So when I hit this endpoint, I had a certificate active already. You will have some endpoints where you absolutely need the user to give you a certificate or you cannot proceed. Notice this could have been null. This certificate could have been null. And I'm not doing any null checks. The reason I'm not doing any null checks is because I have this require certificate annotation here. So let me go here. I'm going to stop using the certificate and notice I'm going to zoom this in. I wish Lagrange would zoom it in for me, but we'll work around that. It says your attendance is requested. Access to this requested requires identification via a client certificate, right? So if you put that annotation on there and the request comes in without a certificate, it's going to bounce back with a certificate required status code, right? So that'll tell the user, hey, activate your certificate. Ugh. Okay, very cool. That required certificate guarantees that you will get a certificate when that endpoint runs. So that's a nice handy method. Let's now reactivate. First, let's get rid of this whole thingamabobber. We will reactivate this and then go home. Okay, this is where we got to so far. Now things are going to get a little bit advanced. So I'm going to click on this thing, and this is saying, who are you? This is some fuddy-duddy stuff that I put in there. But you can see that it's giving me server info. Why is it giving me server info? Well, let's go to the server info controller. Let's go to, is it in context? Yeah, it's in context. So here's the server info controller, and I have an at context here for the server info object. What is happening? Because there's nothing in the protocol that says you have to include server info or yada, yada, yada. Well, what's happening is I'm actually injecting this server info class into the request context. You actually have a provision using my sort of server framework to intercept the request before it gets to the static content resolver or the dynamic routing. Before it even gets to that stage, you can intercept it and then do some pre-processing. And let me show you where that happens. It happens in the context preprocessor, most likely. Let me go down here. And yeah, there it is. Here's my server info object, and I am adding it to the context here. So let's slow down. A lot to take in here. This is the annotation when you want to tell my library that, hey, this class, whatever this class is, it is a preprocessor. Whenever you put this annotation on here, you have to also implement this interface, the request interceptor interface. And you got to override this method, of course, because it comes with the interface. And what you get here is the request context. And you can pull things out of the request context and put things into the request context. Just to talk about this a little bit, under the hood, I'm just gonna click raw. Can I do that? Oh, that's horrible. Wait. Yeah. Okay. So under the hood, what's happening with this request context is um, it's essentially a wrapper around a map that maps an assignable type to an instance of that type. Now, it's a write once wrapper. So if I tried to add another server info to it, that would cause a runtime error. We do this for security reasons, but in general, the request context is something you can add to, but you can't remove from it, and you can't add another instance of the same thing into it once you've added it previously. So I think that may have been TMI. Maybe I should have let you read the docs on that one, but it's important because all of this has security implications, which I'll talk about shortly. Also, you have this really interesting return type here, optional Gemini response. What does that mean? You have the option to return a Gemini response from an interceptor. And if you do that, it short circuits the lifetime of that request, because I will take that Gemini response and return it right away. So you can start to see like the beginnings of like an auth handler here. So hopefully you guys caught that. Now you can have, because there's another thing I gotta explain, which what is this stuff going on? So you can have more than one preprocessors, and they will run in order based on priority, lowest being first, right? So I have -100 here to tell my library that run this first before everything, and that's what's happening. So I'm gonna pause here and give you a second to take it in, and now I'm going to just real quick blitz through everything I've explained here. Preprocessor tells my library that this class, whatever class you define here, will be intercepting requests. You must also implement this interface if you're going to put this annotation on here. My library will fail fast if you don't do that. This interface makes you override this method. This method has a return type optional Gemini response. If you return optional.empty, that request will continue forward to static resolving, and then eventually, if there's no static resource, dynamic resolving. You have the option to add actual things to this context that are outside of the Gemini Protocol specification. So in this case, I'm just adding the server info object, which is just like a record that I'm shoving in there. But you can only add one instance of any given assignable type to this context. You can have more than one preprocessor, and the way you order those preprocessor is by defining a priority. Okay, that was a lot. Maybe I should do a take two, but you kind of need to know that before we go into the next sort of bit of this whole thing, which is, let's go back here. Who am I? Timer certificate. Okay, go home. Okay. All right. That was the hardest part. I think we're over the security hump. Over the context hump. Like, if you understood everything I just told you, I think you're going to understand how we do security in this server. So let's sort of look at a text version, right? There's no demos on this particular page. It's just text. But I'm going to go through a text version, and then I'm going to show you the demos. Okay. So there is a magic object that you can add to the context that my server library will understand, and that is called the grant object. The simplest form of that is the authorized grant. If I add an authorized grant to my context, that request will now be able to bypass any handler that has this annotation on it. The reason I call this the simplest grant is because it's a straight up Boolean check. Is the grant an authorized grant or not? Okay, so there's something called authority pattern, which is just a preprocessor, just like the one I showed you, but the only thing it does is it puts grants into the request context. Okay, so you could have an authority that checks your database. Hey, is this user kosher? And based on that, database check, you can be like, all right, let's grant dot authorize this guy or person. Sorry. Now, of course, there are other types of grants, right? Like, so you have a clearance grant. A clearance grant, you're thinking security clearances, right? You check your database and you think, okay, well, this person should have a security clearance of 2. Well, now, using this grant, it can bypass an @required clearance of level 2 or higher, right? It'll be able to, level 2 or lower. So a grant of clearance 2 will be able to access this handler, any handler annotated with this thing, but it won't be able to access required clearance level 3 because it just doesn't have the clearance to do that. And this is the kind of grant you want to use for like a hierarchical access structure. So think, guest, user, mod, admin, super user type of thing. And you can even have like a class that sort of, explicitly spells that out. This is probably a good practice. We also have a scoped grant. So instead of, trying to, classify the user as a whole, you can say, okay, this user has access to this feature and this feature, but not that feature. The grant should have all the scopes required by a particular endpoint before that endpoint will run. And finally, this is the most special type of grant, which is the denied grant. A denied grant is a grant that can never, ever satisfy the requirements of any of these annotations. Now, if you don't have a deny grant, if you choose not to add a deny grant, likely the request will not be able to bypass them anyways, but it is best practice to add a deny grant. Why? Because you are explicitly and irrevocably telling your application that this request cannot be allowed to access sensitive information. So it's always best practice for an authority to deny a request. Now I've been calling these grant types here, and even down here I'm saying grant type, but a better way to think about these different kinds of grants is thinking about them as dimensions, because they're all independent from each other. A grant that's authorized does not necessarily mean that it has a clearance or a scope. A grant that has a clearance does not mean that it's authorized or that it has a scope. And similarly, if you have some set of scopes, doesn't mean you have a clearance or you're authorized. And one last thing is grants are decoupled from certificates. Okay, so if you have these annotations on there, it doesn't mean that request came in with a certificate. Okay, so this is a really nice write-up to sort of explain everything slowly. Now let's look at some demos. Sorry for the jump cut, but I had to put the kids to bed. I think last we left off, I just finished explaining this sort of security model, and we were heading into demos. So let's take a look here. I'm going to activate this X certificate, and then let's go to the simplest grant. Just to explain the setup here, I have two sort of authorities here, and what this is checking is it's going to look at the name of the certificate. If that name happens to be an A, it'll give me this grant. If the name happens to have be just C, it'll give me this grant. If it's just S, it'll give me these scopes. And as long as I have a grant, it'll give that to me, and then continue onward. And then I have another one. I have another authority. If I go back here, that will run after. And if I have not been awarded a grant yet, it's going to now check if I have all three of those, and then give me all three. That will become more apparent later. Grant also has a builder pattern where you can add multiple things to it. You can add, authorized. You can add a clearance, add scopes, and then build it all the way at the end. And it'll, construct a grant across all three dimensions. So that's the setup for the demo. Let's look at how required authorized works here with an invalid certificate. So if it's an invalid certificate, essentially what this page is saying is try to enter this room. If I try to enter this room with an invalid certificate, I can't get in. I say, hey, you provided a valid certificate, but it's not authorized, right? That's what it's telling me. But now, if I instead use this certificate and then I enter the room, all of a sudden it will serve up the room. And just to show you in code where that's happening, here's the actual page that was being served up. And then down here, this is where I have the @authorized. Now, these require authorized, require clearance, require scopes, have this message thing. But in production, I recommend you not overwrite this message. You don't want to give threat actors visibility into how you're doing your authentication. Just leave it as the default message, which is access denied. It gives them the least amount of visibility. Very cool. Alrighty, so we can see that the authorized grant is working. Let's now go back to the homepage, and you can see here that the next demo is for clearance grants, and that is the C certificate. Switch back to X for a second. You can see that when I switch back to X, it's not giving me anything. In fact, if I go to Authority 2 here, it's just going to sort of give me an empty grant here. So that is the lowest possible level you can get. I'm going to try and access these user areas, and it won't let me. But if I give myself a clearance grant, and this one is a level 3 grant, I should now be able to access all three of these areas. And you can see that I can access all three areas. Okay, very cool. The next one, I think I can just click this one, but just for my own sanity, I'm going to click it from the menu. The next one is scopes. Oh wait, I gotta show you. Clearance controller. This is the clearance controller. You can see that this is the page we were at, and then require clearance. This is the room for level 1, level 2, and then level 3. Again, I have to reiterate, best not to override the message. You can if you want to, but for security purposes, just leave the message alone. Okay, very cool. Let's see here. So this is the S scope. I'm going to switch back to X for a second. You can see this one does not have any scopes. When I switch to S, now I have read and write scopes. So I should be able to read. I can. I should also be able to write, but I cannot delete because I don't have that scope. And just to show you what that looks like in code, scope controller. So here is the scope for read, scope for write, and then scope for delete. And of course, our authorities here only give you read and write. Well, very cool. Let's go back to our home. Let's look at what is next here. Okay, now we get to the fun part. So remember when I said that these grant types are actually dimensions because they're independent? Well, you can think of them as dimensions because not only are they independent, all three of them can be active at the same time. And we saw a little taste of that in this second authority, like this authority 2. You can use a builder pattern here to add multiple different dimensions to a grant. Now if I click into this, you can see the way you would do this on a handler is just to stack them. And what this is saying is the grant has to be authorized and have a level 3 and have these 2 scopes to access this endpoint. And in our case, we have to have all 3 letters in there at the same time to be able to access this triple locked room. I'm going to use this sort of X1 first and click on here, and you can see that it is not authorized. But if I use this special one, now I'm in. Very cool. Alrighty, and this builder pattern that you see here is strictly AND, right? These are AND semantics. So if we go back home, what happens if you have a more complicated kind of check, like, hey, I want it to be authorized or have these scopes, and it's got to have clearances, or something like that, like anything more complicated. So this is the most advanced security pattern. It's actually not that hard if you understood this. Like, this was the hardest section. If you understood that, this guard pattern is not that hard. So under the hood, what these annotations are doing is they're using this authorization object, right? So if you say go to these and use these require authorized, require clearance, blah, 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 blah. Under the hood, those are just using an authorization object that has methods that say require authorized, require clearance, require scopes. And you can actually use those authorizations without the annotation inside a request interceptor. And you can see an example of OR logic, right? You have an authorization, require clearance, require scopes, and then in the interceptor, you can see that, for a given URI, you're going to check the grant, or check to see if the grant has the clearance, or the grant has the right scope. So that's how you would do anything more complicated than AND semantics, right? Instead of stacking annotations, you would have to add a preprocessor that executes later on for that given URI path. So I don't know what demo I have here, but it says, okay, this one requires either a C or an S. So let's switch to A real quick, which has neither. Should not allow me in. Very good. If I do C, it should allow me in. Very good. And if I do S, it should also allow me in. Very good. Okay, let's go back home. And if I have both, of course, that should allow me in. So let's take a look at that. Yeah. Okay. So I keep mentioning guard pattern. Like what's going on there? So a guard pattern is a preprocessor or a request interceptor that specializes in protecting a route or a set of routes. It could be to a static resource or to a controller resource, but you're actually manually writing the logic to protect that particular resource. So there you have it, right? Like how you're essentially just returning. So if, for example, this check fails, you're just returning a Gemini response dot, certificate not authorized. Like that's all you're doing. So you have two patterns of preprocessors, which is authority, and then you have guard pattern. Now I'm sure there's other uses for it. I'm sure you guys will figure that out if you're using the library, but you can see that you can do pretty much anything here with this library. It should cover like 99% of everybody's use case. Put a lot of effort into making sure that it could. So I hope we will use it sometime soon. One last section, error handling. So we have one more annotation that I'm showing off here, which is the @Gemini exception handler annotation. So let's take a look at that, and that should finish it off. What was that? Source global exception handler. Oh, okay. I understand what's going on here. Okay. If I go here and click into errors, you will see the error demo controller, which all it does is throws an error. That's all it does. And this is a custom exception. If I go back into errors, here's my custom exception. This is what the error message says. And then we have this exception handler. Right? You have one of these per application, and what this lets you do is if your application code throws any kind of exception, whether it's yours or somebody else's, you can configure this exception handler to handle that and convert that into an appropriate Gemini response. So the handler threw the error, the exception handler, the Gemini exception handler, caught the error and converted it into a response, and then this one printed out the message, right? This e.getMessage is right here. So you can do this for like, custom 404 pages, custom internal server error pages. So this one is something broke, and it'll print out the actual error. So this is how we do sort of exception handling. I think that's enough for this particular video. There's a lot more I can show you. Like for example, configs. Configs can be programmatic. That you don't have to have an application properties. You could have multiple such files, and your config could reference files programmatically. That's totally in field. But you have a ton of provision here to make a really robust application. And you know, given based on other such frameworks, this is actually fairly lightweight. I'm not relying on Spring. Well, let me say it again. I rely on very few components of Spring. Okay, but there is no application context. There is no heavy machinery. Um, like for example, I'll give you constructor level dependency injection and like an add component annotation, but you won't have all this extra complications with like, oh, I'll double check setters for you. And so I try to keep it as lightweight as possible, but still very ergonomic. Thank you very much. Hope to hear from you soon.